Hello students, in today's lecture we are going to learn about vectors and this is theory part. Disclaimer: the images, text and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the content immediately. Please note that parts of the content may have been generated using generative AI, which is experimental. So, our topic is vectors. So, vector is very important in class 11th. Why this chapter is very important? Because they are used in almost every chapter, such as motion, motion in a plane, motion in a straight line, laws of motion, or like topics, momentum, and even electricity and magnetism. So this is very important topic. Vectors helps us represent physical quantities that have both magnitude and direction, like displacement, velocity, acceleration and force. So a strong understanding of vectors will give you clearly in solving numerical problems and help you truly understand how physics works in the real world. So this is very important. In physics, we can classify quantities as scalars and vectors. So there are two types of physical quantities: scalar quantity and vector quantities. So here question arises, what is scalar and vectors? So scalar is a physical quantity which has only magnitude, but vectors is a physical quantity which has both scalars and magnitude and direction. Basically, the main difference here is direction. So difference is associated with depth vector, that is direction only. So we know vector has both magnitude and direction, whereas a scalar quantity is a quantity which has magnitude only magnitude. So here question arises, what is magnitude? It is specified completely by a single number along with their proper unit. It means what? Suppose we have a sugar, we can say 10 kg sugar. So the magnitude term is 10 only. So this is just a single number or just a digit and along with their proper unit. So what is the unit? The kg. So this is a scalar quantity. And when we talk about the direction, so in that case the quantity will change. For example, distance between 2 points. Look at here, we have a 2 points, point A and another points, point B, and the distance between point A and point B is 2 meter. It means the magnitude is 2 meter. And what is the unit? Unit is meter. It means distance is a scalar quantity. Similarly, another example is mass of an object. We can say mass of a body is a 10 kg. 10 kg. It means magnitude term is 10 along with their proper unit, and that unit is here kg. So this is also a scalar quantity. Like temperature. Temperature is a scalar quantity because we know 10 degrees Celsius. 10 degree Celsius. Here unit is degree Celsius and magnitude term is 10. So these are the examples of scalars because there is a no direction. And one more example is time. Time just explain certain events like a 2 second time is 2 second, 3 second. So what is here magnitude? So here magnitude is 2 and along with their proper unit and the unit is second. Similarly 3 second magnitude is 3 and unit is second. So this is the scalar quantity. The rules for combining scalars are the rules of ordinary algebra. To combine two scalar quantity, we will use simple ordinary algebra. How? Suppose we have a two quantity 5 plus 5. So it will be what? 10. Similarly, we can add two scalar quantity with along with their proper unit. Suppose 1 kg plus 1 kg is equal to what? Is equal to 2 kg. So scalars follow rules of ordinary algebra. Scalars can be added. We can add scalars, subtracted, multiplied and divided just as ordinary numbers. I hope this is clear. For example, if the length and breadth of a rectangle are 1.0 meter and 0.5 meter. So suppose we have a rectangle and the length is 1 and breadth is 0.5. Then what is the perimeter of the rectangle? We can add the sides of the rectangle and that is 0.1 meter, 0.5 meter, 1.0 meter and 0.5 meter. So when we add all these terms, you will be get 3.0 meter. Look at here. The magnitude term is what? Is 3.0 and unit is what? Unit is meter. So this is a scalar quantity along with their proper unit. The length of each side of a scalar and perimeter is also a scalar. It means what? It means suppose we have a length or we can say side of any shape, and if the side or we can say length of any shape is a scalar quantity, so the perimeter or we can say the area, that will also a scalar. If we talk about the rectangle, length and breadth is scalar quantity and perimeter is also scalar quantity. So scalar means just a digit along with their proper unit. Take another example. Suppose we have a two temperature, maximum temperature and minimum temperature on a particular day. So maximum temperature is 35.6 degrees Celsius and minimum temperature is 24.2 degrees Celsius. Clear? Now what will be the difference? The difference is 11.4 degrees Celsius. It means scalars follow the ordinary algebra rules along with their proper unit. So temperature is a scalar quantity. Similarly, if we talk about a solid cube of aluminium of size 10 centimeter and mass 2.7 kg, then its volume is 10 raised to the power minus 3 meter cube and its density is 2.7 into 10 raised to the power minus 3 kg meter per meter cube. So it is also a scalar quantity. Here our main focus to know about the difference between scalars and vectors. Vectors. So here question arises, what is vectors? A vector is a quantity that has a both magnitude and direction, and always triangle law of vector addition, or equivalently the parallelogram law of addition. It means uh, we can add vectors using two laws, triangle law and parallelogram. In upcoming lectures, we will discuss triangle law of vector addition and parallelogram law of vector addition in very briefly. We can add vectors using two laws, triangle law of vector addition and parallelogram law of vector addition. So vector is specified by giving its magnitude by a number and its direction. Vector has magnitude and direction. Some physical quantities that are represented by vectors. So here are some examples of vectors, like displacement. Displacement is vector quantity because it has both magnitude and direction. Clear? Velocity, acceleration and force. Force is a vector quantity. To represent a vector, we use a bold space, or we can say bold face. Thus, a velocity vector can be represented by symbol v. So this symbol is bold. So this is the representation of vector. One another method, or we can say one another representation of vector, that is, suppose we have a vector a. So put a arrow on a vector a. So this is the representation. Arrow, when we imagine an arrow, this one. So length of the vector, the length of the vector is magnitude from here to here, and arrow represent direction. What is arrow? Arrow is direction, and length of this arrow, this one, is the length, or we can say magnitude of the vector. So now we will learn about the positions and displacement vectors. After that, we will talk about some more examples about vector, like weight is. So look at here, A and B. To describe the position of an object moving in a plane. So suppose we have an object. The position of the object at point P, and after some time the position of an object will changes from P point to P prime. This is, listen carefully, this is very important. We need to choose a convenient point, say O as a origin. So P and P prime, the positions of the object, and T and T prime at T and T prime respectively. So at time T, the position of object is P, and at time T prime, the position is P prime. The important point here is this, from origin to point P represent the position of object. Similarly, from origin to point P prime is a position vector of the particle. So to how we can know is any value, or we can say R is a position or not. Position vector originate from origin. Look at here, x-axis and y-axis, and O is the origin. So the here R vector, or we can say this one, OP is a position vector. Similarly, OP prime is a position vector. It means position vector originate from origin. We join O and P by a straight line. Then OP is the position vector of object, at time t, and an arrow is marked at the head of this line. It is represented by symbol r. So OP is equal to r vector. So OP represent position. Clear? Now if we talk about the r prime, so is r prime is position vector or not? Yes, r prime is a position vector. Look at here. Point P prime is represented by another position of vector OP prime. So OP prime is also a position vector that is denoted by r prime. And length of the vector r represents the magnitude of the vector from point O to point P. The length of the arrow represent the magnitude of the vector. And suppose the particle is changes position P to P prime. In that case, what is the PP prime? What is the PP prime? PP prime is a displacement vector. So if the object moves from P to P prime, P to P prime, the vector PP prime with tail at P and tip at P prime is called displacement vector, because the particle changes position from at point P to at point P prime. So it is important to note that displacement vector is the straight line joining the initial and final position. So look at here, and P prime and P prime P and P prime is what? This shows the position of the particle. Initial position is P and final position is P prime, and does not depend on the actual path undertaken by the object between the two positions. It means displacement, this is very important. Displacement is a vector quantity. It depends on initial and final position. If the initial and final position is same, in that case the value of the displacement is equal to 0. So for example, given initial and final positions as P and Q, look at here, initial position is P and final position is Q. The displacement vector is same PQ for different parts of journey, and that parts of journey is PA, BCQ, PDQ and PBEFQ. Suppose, this concept is very important. Suppose the initial position is P at t, after some time at t prime, the position of the particle at Q. Now after some time again the position is same at P. It means the initial and final position is same. So what will be the displacement? 0, 1, 2, 3 and 4. The displacement is 0, because displacement vector depends on initial and final position. If the initial and final position is same, the displacement vector should be 0. Therefore, the magnitude of displacement is either less or equal to the path length of an object between 2 points. Now we will learn types of vectors. So our first vector is equality of vectors. Look at here, there is a two vector, vector A and vector B, or we can say OP vector and QS vector. Two vectors A vector and V vector are said to be equal. The condition is if and only if they have same magnitude and same direction. So look at here, figure A. So OP vector and QS vector, the length of the arrow is same, or the direction is same, because both are parallel to each other, both are parallel. It means they are equal vectors. Figure A shows two equal vectors, A vector and B vector. We can easily check their equality. How we can check? Shift B parallel to itself until its tail Q coincide with the tail of A, and that is Q coincides with O. So in that case, A and B are equal vector. Clear? Since tips S and P also coincide, the two vectors are equal. A vector equal to 2 vector. Now tell me what is here head and tail. We have a vector A vector, or we can say OP vector. The tail is this one, O point, and head is P. Look at here, figure B. In general, equality is indicated as A vector is equal to B vector. Note that in figure B, vectors A prime and B prime have the same magnitude, but they are not scalar. Why they are not scalar? Because the direction of vector A prime and vector B prime are different. Due to this, A vector and B vector are unequal vectors. Even if we shift B prime parallel to itself so that its tail Q prime coincides with the tail O prime of A prime vector, the tips S prime of B prime does not coincide with tip P prime of A prime. So to check the equality, you need to just coincide the points. Here we have O prime, P prime, and Q prime and S prime. So if both points are coincide, in that case the vector is equal and with parallel direction. And if the points are not coincide, so we can say it is unequal vector. Multiplication of vectors by real numbers. So multiplying a vector A with a positive number lambda. Suppose lambda is any number 1, 2, 3, 4. So it gives a vector whose magnitude is changed by the factor lambda. Is the direction is changed or not? No, direction is same as that of A vector. So this is a rule. Mode of lambda A vector is equal to lambda mode of lambda A vector if lambda is positive. For example, if A vector is multiplied by 2, the resultant vector 2A in same direction as A and has magnitude twice of A vector. So as shown in this figure, A. So the here vector A and vector 2A vector, the direction is same but magnitude is different. Why? Because it is multiplied by 2. Look at figure B. There is a 2 vector, A vector, and second one is minus A vector. What is the main difference of vector A and minus A vector? Because the direction is opposite. Multiplying a vector A by a negative number, that is minus lambda, it can be -1, -2, -3 and so on, gives another vector whose direction is opposite to the direction of A vector and whose magnitude is lambda times of mode of vector A. Multiplying a given vector A by another negative number, we can say that negative number is -1, -1.5, then what will be the change? So magnitude and direction both will be changed because they are have with negative sign. Now we will learn parallelogram law of vector addition, and this is very useful for upcoming lectures like motion in a straight line, motion in a plane, laws of motion, work energy power, gravitation. So parallelogram law of vector addition is a very important. If two vectors are arranged head to head or tail to tail, then parallelogram law of vector addition is carried out. So before knowing about the parallelogram law of vector addition, suppose we have an arrow, this one. So the head is, listen carefully, head is this one and tail is this one. If we talk about head to head, it means what? Like head to head means, suppose we have a vector A and another vector B. So this head to head, or we can say head to tail. Head to tail means this one is head and tail is this one. So this is the meaning of head to tail. And what about to tail to tail? So this is arrow, or we can, this is a vector, the tail point is this one and another this one. So tail to tail. Now in tail to tail, so if two vectors are considered to be the adjacent sides of a parallelogram, then the resultant of two vectors is given by the vector that is diagonal passing through the point of contact of two vectors. We will learn law of parallelogram addition of vectors step by step by using method. So method is what? Step by step addition of two vectors using parallelogram law of vector addition is given below. So our first step is consider two vectors. Consider two vectors. So we have a two vector, A vector and B vector. Now next step is what? Our step second is A vector and V vector. We consider two vector. Now bring the tail of vector A, tail of vector A to tail of vector B, tail of vector B. Here the direction of vector is not changed. Now step third is what? After bringing the tail of vector, when we bring the tail of vector A and tail of vector B. So third method is draw a lines parallel to vector A and vector B. So look at here, the line is OS. Next step, so OS is a diagonal vector, or we can say diagonal of this parallelogram. Join O and S by a straight line with an arrow pointing towards the S. The arrow of the OS vector pointing towards S. This is a diagonal of parallelogram, or we can say this is the resultant of the vector A and vector B, and this is the resultant vector. So our main point to find here, uh, to know to calculate resultant vector. So A vector and V vector, by using the parallelogram law of vector addition, the diagonal vector of this parallelogram is the resultant vector. So A vector plus B vector is equal to R vector. Now in next step, look at here, OQ and PS both are parallel, yes or no? Similarly, OP and QS parallel, yes or no? So it means if we substitute the OQ vector, OQ vector, OQ vector at with PS vector, in that case it become a triangle. So like suppose we have a vector A and second is vector B according to parallelogram of law of vector addition, A vector and B vector. Now draw a parallel lines, draw a parallel lines like this. So B vector and suppose this one is S and this is P, and B vector and PS vector both are parallel. So just take the name of this vector is B and remove this. Clear? So resultant is R. Triangle law of vector addition. When two vectors are represented by two sides of a triangle in a magnitude and direction were taken in same order, then the third side of triangle represents in magnitude and direction the resultant of the vectors. It method. So here we will learn triangle of vector addition step by step. First step is consider two vector, vector A and vector B. So we have a two vector like this, A vector and B vector. After that, our step second is bring the head of vector A and tail of vector B like this, head of vector A and tail of vector B. Now what will be the resultant vector? So step 3, our join the tail of vector A. The tail of vector A is this one with head of vector B. So head of vector is this one. When we join, so this will become resultant vector by a straight line with an arrow pointing towards head or head of vector. So the new vector is the resultant vector, and that is vector C. Look at here, C vector is the resultant vector, or we know this is vector C vector. So the resultant vector is A vector plus B vector is equal to C vector. This one, look at here, this is the clear representation of the triangle law of vector addition. A vector, V vector, and the resultant vector is C vector. Now magnitude of a vector. How we can calculate the magnitude of vector? Look at here, this is coordinate system, x-axis and y-axis. and we have a 2 points in a plane, A point and B point, and the position of point A is x0, y0, and the position of point B is x1, y1. So suppose AB is a vector, AB is vector, and we have to find the here magnitude of the vector A. So to calculate the magnitude of vector AB, firstly we calculate the distance between initial point A and end point B. Look at here, initial point is A and final point is B. How we can calculate the distance? We can calculate distance using the distance formula. To calculate the magnitude of vector AB, we use the calculate the distance between initial point and end point. In xy plane, let A coordinates is x0, y0 and B coordinates x1, y1. Therefore, by using the distance formula, the magnitude of vector AB is equal to under root x1 minus x0 whole square plus y1 minus y0 whole square. So suppose first we find x0 or y0. Suppose the x0 is this one and the value is 1. Solve this with me. And similarly y0 is 2. And A, if we talk about x1 or y1, so x1 is 3 and y1 is 4. So its coordinates become A, the coordinates of A is 1 and 2 and coordinates of B is what? 3 and 4. Now find the distance of AB. What is the answer? So just substitute the value of x1 and x0, y1 and y0 in the given formula. You will be get correct answer. So x1 is what? X1 is 3 and y1 is x0 is what? X0 is 1. So square plus, and y1 is what? Y1 is 4 and y0 is what? Y0 is 2. So solve this. So under root 2 square plus 4 minus 2, 2. So it will be 4 plus 4. So it is root 8. Or we can say 2 root 2. So using this formula, we can calculate the magnitude of the vector. Now if the starting point is at xy and the ending point is origin. Suppose if the ending point is origin, then what will be the coordinates? 0, 0. 0, 0. The value of x is 0 and value of y is also 0. Then magnitude of vector become this one, under root x square plus y square. Clear? Unit vector. So here question arises, what is unit vector? A vector having a unit magnitude is called unit vector. What is the meaning of unit magnitude? Unit magnitude means 1, just with unit vector. And suppose the unit vector is n cap, the direction is n cap. So this is the representation of unit vector. It is used to denote the direction of a given vector. So suppose we have a vector, and what will be the magnitude and direction? The magnitude is a vector uh, the magnitude of vector A is A and direction is A cap. Suppose we talk about another. Suppose we have a vector B. So how we can write magnitude and direction? So the magnitude will be B and direction is B cap. Suppose this one. So this is the representation of unit vector. A vector is the unit vector along with the direction of A vector. Clear? Subtraction of vectors. Subtraction of vectors can be defined in terms of addition of vectors using triangle law of vector addition and parallelogram law of addition. So the difference between two vectors, so here vector A and vector B can be write A vector and minus B vector. So look at here, we have a vector A and vector B, and third vector minus vector B. What is the difference between B vector and minus B vector? The only difference is direction is opposite. So A vector minus B vector is equal to A vector plus B vector. And what is B vector? That is minus B. So it is shown in figure, in given figure. Look at here. Minus B vector is added to vector A. Minus B vector is added to vector A. In that case, the resultant vector is what? This one. A vector minus V vector. We know R vector is what? Sum of A vector plus B vector. So here our B vector is what? Minus V vector. Just substitute. So you will be get A vector minus V vector. And the suppose we have a two vector A vector and V vector. In that case, the resultant vector is A vector plus B vector. Clear? Suppose we have a two vectors A vector and V vector. To add these vectors, we bring their tails to a common origin O. Then we draw a line from a head of A parallel to B and another line from head of B parallel to A to complete a parallelogram OQSP. So parallelogram law of vector addition we already learned. One example for you. Please solve this question. A rain is falling vertically with speed of 35 meter per second. Wind starting blowing after some time with speed 12 meter per second in east to west direction. In which direction should a boy waiting at a bus stop hold his umbrella? Solution. So according to question, look at here, the velocity of rain and wind are represented by vectors VR. VR means velocity of rain. VW velocity of wind. And direction of in this question is what? So here we will use the vector law of addition. So winds starts blowing after some time in east to west direction. So that look at here, north, south, east, west. East to west, the east direction is this one. East to west means like this. East to west, east to west. So this is the direction of wind. And rain following vertically downward. Now what will be the angle? Theta. So to find out the value R, or we can say resultant vector, we will use vector law of addition. So r vector is equal to under root square of velocity, square of velocity of speed of rain and square of velocity of wind. So what is Vr? That is 35. So squaring 35, you will be get 30. The square of 35 is what? This one, 1225, and square of 12 is what? 144. So it will be plus 144 under root. So after adding and take square root, you will be get r is equal to 37 meter per second. The direction theta that r makes with vertical, look at here. How we can calculate theta? Using the formula. And what is formula? So tan theta is equal to VW divided by VR. So VR is VW is 12 and VR is 35. So it will be what? It will be 0.343. Now tan theta is equal to 0.343. So theta become tan inverse 0.343, and the value of tan inverse 0.343 is 90 degree. Clear? It means boy should hold his umbrella in vertical plane at angle 90 degree with the vertical towards east. I hope this is clear. Yes or no? So this is very important formula of the resultant vector. R vector is equal to this one, or we can say vector A plus vector B. Clear? Or we can say if we want to calculate the resultant vector, we already learned that is under root vector A square, vector A vector plus B vector. Clear? Thank you for your attention. Within 1 or 2 minutes, your chemistry class will start.